So in 4.7, we're going to be graphing systems of linear inequalities. And so what we're going to work on is reviewing some of our graphing techniques and then how that relates to inequalities. Okay, so in this system, you see you have two inequalities. Okay, so there's an inequality up here. I'll call it number 1. So I'm going to go down here and write x plus 4y, but I'm not going to put greater than or equal to, I'm going to put equals 10. Because what we want to do is we want to graph the boundary line, and so we have to graph the equation. Now, you could make a table of values. That's one way to do this. Let's do it that way this time. X and y. So maybe I want to pick 1 for y and 5 for x. Now, you might say, well, how are you getting that? So I just kind of eyeballed it, really, to be honest. But if I put in a 1, oh, I did it wrong too, didn't I? Dang it. Okay, if I put in, I'm not going to get 5, I'm going to get 6. So you subtract 4, and you get x equals 6. Okay, so let me fix that mistake. I'll make mistakes. Oops, that's my eraser. Okay, so we'll try again. 6. All right, and maybe we want to put in 0 for y. Okay, and then if I put in 0 for y, I would have x equals 10, because 4 times 0 would just be 0, so I'd get a 10 over here. And then what else is a good number to pick? Maybe I want to pick 2 for y. So let's let y be 2. And if I plug in a 2 for y, and you might say, well, why are you choosing y's? We usually choose x's. Well, I'm choosing the y's in this case because it's 4y, so I thought it'd be easier if I didn't have to do dividing and a bunch of fractions. So I'm choosing to kind of take care of the 4 with the multiplication, and then I can figure out what x is. There's other ways to graph, but this is, so I'm getting x equals 2. Okay. Well, I have 3 points. If they line up, I'm going to feel much better, and I'm going to go ahead and graph those now. So 6, 1, 2, 3, 4, 5, 6, 1, and 10, 0, and 2, 2. Okay, they look like they line up pretty good. Now, before I draw the line, I have to make sure, is it a solid line or is it a dotted line? It's a solid line because it's greater than or equal to, because it has the equal to part. Now, it'd be nice if I'd drawn a straighter line, but I didn't. Okay, now we pick a point not on the line, so I'm going to pick 0, 0 because it's usually easiest. And I'm going to plug that point in, so choose 0, 0. You don't have to, you can pick another point that's not on the line, but 0, 0 is a ways away. And I'm going to see if it's true. 0 plus 4 times 0, is that greater than or equal to 10? I don't think so, because I'm going to get 0 is greater than or equal to 10. No. So what does that mean? It means the point that I tried, this one right here, that doesn't work. So when I graph, I need to graph the other side. So it's going to be over here. And I really could extend this a little bit. I just can't draw. So I get a full graph there. Okay, that is the inequality, the first inequality, and how it graphs. Now we have to graph the second one. I'm going to do this one with a different method. I think I'll use the slope-intercept method. So I'm going to take 3x minus 2y, and I'm going to make it an equation, equals 12. And then I'm going to subtract 3x from both sides. So I'm going to move the 3x to the other side. And then I'm going to divide everything by -2. So this might bring back some happy memories, hopefully, of putting something in slope-intercept form. And now I'm going to graph using the slope and the y-intercept. So my slope is 3 over 2, and my y-intercept, it's the point 0, -6. But sometimes they just say -6. But Okay, so 0, negative 6. 1, 2, 3, 4, 5, 6. Down here. So I graph that point, the y-intercept, and now I'm going to count the rise over run, the 3 over 2. So I'm going to go up 3 and over 2, and up 3 and over 2. And I can keep going up 3 and over 2, kind of in the blue area now. All right, so I've got my points lined up. Also remember, you could go negative 3, down 3, but you have to go negative 2, back 2, and you can get another point that way. All right, this time it's going to be a dotted line because it's not greater, or it's not less than or equal to, it's just less than. So that's why it's going to be dotted. So I draw my dotted line, or dashed, if you want to call it a dashed line. Okay, now try to ignore the blue line and just think about the green dotted line that I just drew. Okay, pick a point not on the line. So I'm going to pick 0, 0 again because I can. And I'm going to plug it into the original inequality. So the inequality said 3x minus 2y is less than 12. And I'm picking 0, 0. Again, you can pick another point if you want. Zeros are convenient when you're multiplying. And so I get 0 is less than 12. Yes, that is true. So it means that my point 0, 0, I'm trying to make it big there, that point does work. Now remember, you're on the green line. So it's everything on this side of the green line. Okay, you're almost done. Now what we have to do is we have to see, well, where is both the blue and the green? Because those are the points that are going to satisfy the system of linear inequalities here. And so I'm going to use the highlighter. We'll see how well this works. And it's going to be this area here. Oops, I'm a little off there. The highlighter's a little out of my control, but there it is, okay? So sometimes students actually, when we're in class, they'll bring highlighters to class just to do that type of thing. But the yellow area then, those are the points that satisfy the system of inequalities. And the only way to solve this is by graphing. Okay, we will have another example in the next video.